So, for this problem, in the beginning it tells us that y is a function of x such that y prime is greater than 0 for all x. Immediately, what does that mean? Increasing. Increasing. Again, when the first derivative is greater than 0, when the first derivative is greater than 0 for all x, it means the function is increasing. This is the stuff that you need to know. Okay, I don't know what that means. When the second derivative is less than 0 or negative, it's concave down.
I know, right? Wait a minute,
Simply, guys, based on that alone, your answer is B. You don't need any more than that. Okay. The function, remember, you have a second try of this still, so you got a 4 good. I'm glad. But you have to do it again. And the next one, you're going to have to actually go through the curve sketching yourself. Okay, this is the easier version. Again, take a look. Okay. This one is increasing, but it's concave what? Concave up. It's aimed upward. It still is increasing, so that works, but it's not concave down. Increasing, concave down. What is this one?
Decreasing.
Decreasing, concave down. This one is,
No.
it's concave up, then it's concave down. It's increasing, then it's decreasing. So this one is just out of the picture. This one was a little bit trickier, though, because it is increasing the whole time. So if you got this part, you might have chosen that. But look, it's concave up, then it's concave down. It can't be concave up. It's got to be concave down. Okay? If you wrote this out, if you wrote notes and you did it, you got it wrong, you would get partial credit still. Okay? If you just guessed and you got it wrong, it's 0. Okay?
Right there.
But again, guys, do you realize the first quiz doesn't matter unless you get a 4? Have you guys noticed that by now?
Yeah.
Think about it logically. Because the next quiz you take is your real grade. Unless you get 2 4s, then you get a 5. So even if you got a 0 on this, or if you got a 1 on this, it makes no difference. Because if the next time you get a 3, your grade is now a 3.
When my parents come in and ask you about my grades, it's just easy a 1.
Well, we're gonna have the second try of this next week, and I'll talk about that later. Okay. All right. Next problem.
Oh, God, second one B.
That's not mine on the work.
Okay.
Okay, I have to see this one now.
The answer was D. That was the
Oh, I
answer.
did with D.
Yeah, I got it right.
I did with D.
If you just guessed, guys, I know some of you. Can we all do work for
I
this?
guess. I tried to do
I
work.
tried.
That's the equation.
I'm trying to remember the equation.
It does come out.
I mean, just read through. So we got the volume is pi r squared h. The volume is equal to 16 pi. So if pi r squared h equals 16 pi, we solve for h. Solving for h, that's what you get. Now, you want to minimize the surface area, minimize the amount of tin. So you're taking the surface area function, which is right here, this area function, and you're going to minimize it. Now, you can't minimize this because the r and h right away. So you take that h value, you plug it in right there for that one. So you simply plug it in for the h. This is what you get when you simplify. Okay? I'm showing the simplification. I know it's a lot of work, but there is simplification there. Now, when you take the derivative of this, the 2 pi is just a coefficient. It remains in the front. The derivative of this one turns into be negative 2 because you have a negative 1 power rule. This turns out to be a 2 in the front. Put the 2 in the front. Then go ahead and take a look at this. Well, I want to know when it is a minimum or a max. So you set it equal to 0. That's this line right here. Okay? We're taking this value. We say that, okay, well, it's negative for any values between 0 and 2. You end up getting that. For any value greater than this, you get a positive value. So when the radius is 2, sure, that's the answer. But take a look. 2 wasn't an answer, was it? What did it ask for? The height. So you got to take this 2 and plug it back in over here. When you plug in a 2 there, you get 16 over 4. 16 over 4 is 4.
So, cubic inches. Like, inches or cube has nothing to do. Because I thought that was like, it was 16 pi cubed, because it said like cubic inches. So I thought like.
That's the volume. That's why we put equal to the volume.
Well, I thought like, you carry like a cube to the.
To the derivative?
Yeah.
This is the volume formula, so it's cubic inches equals volume. This is the surface area formula, which is just cubic centimeters. When you get your answer in the end, though, it's just going to be centimeters or inches, whatever it was in. Okay? Notice, are there any units on the choices?
No.
Because it's given in the problem. Look, it says, what must be the height in inches? So they do that on the test all the time to avoid having to put units on the choices. It says, what is the height in inches? So let's say hypothetically speaking, and say, what is the height in feet? Well, 4 inches is a third of a foot, so your answer would actually be a third. You see what I'm saying? Again, if it said, what is the height in feet? And you get your answer to be 4 inches. Well, 4 inches is really 1/3 of a foot.
So 1/3 would be the answer.
So the answer would be 1/3 if it said in feet.
So it would be D and E. So it would be the D before.
And I guarantee you, this choice would be here, yeah. To be honest, this is an AP problem. I'm surprised 2 wasn't a choice. Because the radius turned out to be 2, right? And this is like an SAT thing. You get the R, oh, I got it, the radius is 2. But it's not asking for the radius, that's for the height. I'm surprised they don't put 2 as a choice. I don't know. Maybe, maybe not.
When you get, stupid question, but when you get the area, when you get
Here's the area, yeah.
yeah, you took the parts apart, right? So you got the
Correct. This is the lateral area. This is the top base and the bottom base combined.
Okay.
It's like the unfolding in the front. Okay, 2 pi r h. This is the top and the bottom. If you don't memorize these guys, I can't do anything, but you can at least type in your calculator.
Yeah.
Okay? If you really don't feel like memorizing,
memorized it.
I'm not going to care. Go to a program, edit a program, make a new one, and literally just type in the formulas. Okay? Do that if you need to. If you're not going to do that, if you're not going to type it in, please memorize it. Okay? I really don't care which way you do it.
Yeah,
Because it doesn't matter on the test. You can put any program you want in the calculator.
No, but
You can literally write like all of your notes in the calculator for the test.
yeah, there's people that did that already.
I know people that have programs out there that like, it's all the notes from integrals, all the notes from derivatives, all the rules for derivatives, all the rules for integrals, all as programs. You can do that, but you know what? How long is it going to take you on the AP exam to search through all those notes to find what to do, right?
Search function.
You got to know how to actually do it yourself. Okay? Next one.
What?
Man, you finally fast, you got 12 more
What's
pounds.
up, man? Answer the problem. That stuff's so bad. Oh, okay. Oh, wait,
Okay. I'm going to wait till here to mention this, but let's just go ahead and take a look at the actual problem. So, the problem is asking us to find dr dt. That's the first thing you have to notice. A boy is walking at a rate of 10 miles per hour toward the base. So here's the boy. You have to think about what's going on here. How do I know that this is the base?
Because of the first one.
No, the diagram doesn't. No. The flagpole. What is the flagpole's height in the problem, guys? So automatically call this flag and call this the base of the flag.
Because it's hitting the problem. It's hitting the problem.
But that doesn't tell you why this guy's here. It tells you the flag is here. This guy is here because the flag is there.
Yeah, but it's, I mean, it's like understood if you understand, like if you read.
Sure. That's fine. That's fine. Yeah. But I meant, why is this? You know, why is the guy over here? Because the flagpole is over here. Why is the flagpole over here? Because it's in the problem. Sure. So it doesn't say anything about the guy being over here, though. All it tells you is the flagpole is 120. So label it at the flag, label it at the base of the flag. The guy's walking toward it. So immediately, dx dt is what?
10.
10, and he's going this way.
Yeah.
Okay, dx dt is negative 10 miles per hour.
You gotta be kidding me.
Again, he's moving to the left. Think of it as negative. Remember we studied talking that one day about if it's getting closer or not? If you want to just always be safe, left and right. He's moving left, call it negative. Now, that's dx dt. It says, find at what rate or dx dt or dr dt or ds dt rate is the distance from the top of the pole to the person changing. The top of the pole is here, the person is here. The distance is r. The rate it changes is the dr dt.
What is that?
So this problem says find dr dt.
Yeah, is the 50 the dr dt?
No,
What is it?
at the condition when it's 50. So for example, watch. Imagine the guy is here. Now the triangle looks like that, right? Then the guy is here. The triangle looks like that. Then it's here. The triangle looks like that. At some point in time, one of these hypotenuses will be 50. Okay? So you need to figure out the point in time when that is, and then figure out the actual far,
Also,
the
it's
actual.
the
50
hypotenuse.
is the
Rate.
R or 50
R
is
the
the
X.
It's the r, the x.
It's the X.
It says when he is 50 feet from the base. So 50 would be the x, yes.
Okay, okay.
So 50 is here, or 50 is here, or 50 is here. Okay? But we're going to use for the negative theorem.
So what was the answer? Keep
Okay?
going.
No, we're doing the problem. Relax.
I know, but
We'll get to the answer. Relax. We got Pythagorean theorem. We know x squared plus 120 squared equals r squared. Please start with that. That's our equation. Now, differentiating this equation, we're going to see right away that we have dx dt and a dr dt. Okay? See this? We have both of
This is
these.
the river.
We know the value of dx dt is negative 10. Plug that in right there. You know the x value is 50. Plug that in. But the problem is, what's the r value, right?
R is, I know R.
How do you get r?
I took that, whatchamacallit? This, yeah, I took
Easier. I know what you're going to say. Stop. Easier way to do it. I know. You're right, Houston. That's the way to do it. There's an easier way. Anybody do a different way? What is it? 5, 12, 13, isn't it? 50, 20, 120, 130. Did your r come out to be 130?
Yeah.
5, 12, 13 triangle. Remember this triple, guys?
No.
This is, you got to memorize it then, or write in your calculator. 3, 4, 5, 8, 15, 17. Please, people, it saves you so much time. There's 30 seconds right there. So, since this was 50, and this was 120, r must be 130. Again, when x is 50, we plug in the 50 for x, dx dt is negative 10. Well, when x is 50, if it's 50, the 120 is not changing. 5, 12, 13, or 50, 120, 130.
So it's a 5, 12, and
Okay.
so it's a
Special right triangle.
How did those get to there? Like, is it like in a multiplication thing?
You can double all these, but these are not multiplicatives of each other. No. These are 3 completely different ones. These are 3 different triples that can all be multiplied. So you could do 6, 8, 10. You could do 9, 12, 15. Those are all multiples of this one. You could do 10, 24, 26, doubling all
So
those.
those are just.
These are 3 completely different triples. We chose to use this one here. Now again, once that's 130, we plug that in. Let's go ahead and show that.
Sure, we don't class it, right?
After school, no, there's no class today. Again, if you want to show the work, if you wanted to show the work or see it, first again we said x is 50. We said here's our dx dt, and we saw here that, okay, if we do the square, we're going to get 130. That's fine. But again, please do it in your head. So when you plug in all your values, what did I do here? Anybody notice what I did? I solved for dr dt actually. Watch what happens here. Take this equation. See the 2's? Cancel. You want to get dr dt by itself, don't you? Isn't that what we're solving for, dr dt? So move the r over. So divide by r. So x over r times dx dt. X over r times dx dt is what dr dt is. So you could solve for it as a variable, okay, and then plug in. Or you could plug in up here and then solve. It does not matter in this case. Okay? Doing so, though, you're going to get a value of negative 3.85. Now, there are some key things to mention here. First, the value of dr dt is less than the value of dx dt. Who can explain why? Who can explain why?
That's the addition of the 2 legs.
Not the addition of the 2 legs, no.
You said why?
Let's take a look. Our value of dr dt is negative 3.85 miles per hour. Our value of the other one was negative 10. So dr dt is negative 3.85. This is dx dt, sorry, is negative 10. Okay, negative 10. How come this number turned out to be less than this number? No. We're talking about rates. Which has a higher rate? This is they're both negatives, Gary. But this is decreasing at a rate of 10, right? This is decreasing at a rate of 3.85. This is a bigger rate. Bigger in the sense as in faster, okay? Not negative,
This
positive.
is a higher object. No,
Yeah, just the y value have anything to do with it.
Yes and no. Let's take a look at some examples here. I want you to think visually. Here's my first triangle, right? Let's make believe like some time goes by. So maybe a half an hour goes by here. After half an hour, now your triangle might look like this. After another half an hour, then your triangle looks like this. Isn't this value getting really small? Isn't this value not getting that much smaller, really? It still is pretty long. Like, I mean, this is one length, this is another length, this is another. This still has some length to it. Whereas this, the value is pretty much being dissipated completely.
Right.
So this is decreasing at a faster rate here. Okay, so its value is getting smaller faster.
Is it
Whereas
because-
this value,
Oh,
sure, it's getting smaller, but it's not getting smaller as quick. Again, it went from this length to this length. Then it went to this length. It's not getting smaller as fast.
Oh, good. Because it started off originally with longer. So, nothing.
This is a pictorial way of showing it. Let's show it algebraically now. Let's take a look now here. Remember when I solved for dr dt here? Take a look at your fraction. Now, dr dt is what we're looking for. And dx dt was negative 10. Let's make believe I didn't know x and r. Okay? If this number if this number is a fraction less than 1, so say it's 1/2, what would this come out to be? -5. If this was a fraction like 2/3, what would this turn out to be? 2/3 times 10. Give me a decimal, come on. What's 2/3 as a decimal?
6 points.
It's 0.66, right? So times 10, 6 point. Come on, guys.
Look at me.
That's what 2/3 is, right? So if this fraction were 2/3, the rate would just be, because you're multiplying by 10, move the decimal over one spot. So what I'm showing you is this. Whenever this number is a fraction, whenever this value here is a fraction, dr dt turns out to be less than dx dt. And take a look at our problem here. We had x over r. The value of x was given as 50. The value of r was 130. So this turned out to be 50 over 130. So isn't this a fraction less than 1? 5/13 of -10. It's got to be smaller than -10, right? Because it's a fraction times a whole number. It's just going to get smaller. That's all that's going to happen. So here, when we look at our answer, we're able to clarify that. We could say that the reason being is because x is less than r. Because that fraction, this number, turned out to be a number smaller than this number down here.
I also write that with your points.
Say again?
No, I'm just saying, like, let's say I got the whole problem wrong, but I also write like stuff like that.
You can't write that.
If you
It's
write
wrong.
something like that, you get it right.
There's no way to write that. I guess it's right. These are just points that I'm noticing, guys. These are not things that I asked you to answer. The height. Edgar, pick your head up, please. Edgar. Come on. The height of the flagpole plays a role since it's used to calculate the value of r. Even though in the beginning, guys, the 120 does not get affected by derivative. Remember, take a look back up here. Take a look back up here. When you differentiated the 120 squared, what is the derivative of 120? It's just 0. So the derivative of 120 squared is still 0. So when you differentiate, this problem, or this part, drops off. So you want to say to yourself, it doesn't have an effect, right? But later on, when we try to figure out the value of this, we used the 120, didn't we? We said 5, 12, 13. So the 12 does have an effect on the problem, but not effect on the derivative here. Okay, it affects the actual condition you're going to plug in. And then finally, the last thing. Okay, the value of dx dt and dr dt are negative since the person is moving closer to the flagpole or to the left. Okay, if you had drawn it this way, which you could have drawn it this way, but it was given as a diagram, then both of those would have been positives. Okay, keep that in mind. Both of those have been positives. It's a little bit confusing there. So always, whenever you think of something decreasing, draw it as if it's going to the left. Okay. To start the next topic, what we're going to learn next is something called slope fields. What I want to do, though, is take a look and think about our schedule for the next few days. Today's Wednesday. Okay, on Thursday, what I plan to do is slope. Today's Tuesday. Wednesday, you have off. It doesn't matter. Yes, it's true. On Thursday, we're going to do slope fields. Slope fields is not a difficult topic. What you're going to be doing is calculate derivatives over and over and over again. Okay? So you need to know your derivative rules for this. You're going to do a derivative over and over again. You're going to keep evaluating it.
Are we going to be using inverse trig?
No, not as much. There's not really inverse trig here. Slope fields are basic functions, really. They're not complicated functions. That's what's going to be on Thursday. At the end of slope fields, we're done with derivatives, finally, which I wanted to be done with before Christmas. So we're doing not as well as we were doing before. Okay? We're slowly getting further and further behind. We got to keep catching up. The thing after we're done with slope fields, we still have to take our derivatives test. Okay? Which is the test on everything we've done for derivatives for application. So if we go to our syllabus to take a quick look,
That's a midterm. Yeah, exactly. That would have been
we take a quick look here.
That is our midterm. And this one you can't curve.
Okay. The limits are all here. Differentiability. Keep going. Sorry. Keep going. We did chain rule. That was last one. Okay. We started derivative applications. Did we do position velocity in the last one?
No.
I wonder if this was. No, right? This was in derivatives. This was applications. So on our test, we're pretty much going from position, velocity, acceleration, implicit, which is what we did with the dx, dt, dr, dt, stuff like that. Inverse trig functions, mean value theorem, critical points, increasing, decreasing, concavity, curve sketching, optimization, related rates, linearization. We didn't do Newton's method because it's no longer considered on the AP exam. We did differentials instead. And then the last thing we're going to look at is just slope field.
Oh, wow.
Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 topics for this next test. Okay, so derivative applications, there are 12 of them. We still have not done, we did our first test on curve sketching today. We did our first test on optimization and related rates. We have to do our second curve sketching, our second optimization, our second related rates, and we still haven't looked at things for this because I didn't give you homework yet. I have to give you homework still for this. And slope fields we're starting on Thursday. So in the next week or two, we're going to start our next topic, which is integrals, but we're also going to be taking our test on derivatives.
Next week?
Okay? Next week we're going to start integrals, but we're still going to be taking our test on this. So my plan for you guys is this. We spend Thursday, I can bring up my calendar so you can see. We spend Thursday doing slope fields, okay? We're only going to take about 1 day on that. We spend Friday of this week just reviewing the general idea of all the derivative applications. Now, I put derivative test for Monday. We could do it Tuesday if you want. It doesn't matter to me. But if we do it on Tuesday, then we're learning something new on Monday. Okay, just keep that in mind. Again, on Thursday, we'll do slope fields. It should only take us 1 period to get through slope fields. They're very straightforward.
Think about two.
We're going to do a review of derivatives. The problem here on Monday is that we might run out of time because of assemblies on Mondays, okay? So I don't like to do it on Monday. So if we back it up to Tuesday, we can. That's no problem. We can move it.
We can't do something new on Friday and put the review to Monday?
There's nothing new to do. There's nothing new on derivatives left.
No, I know, but I'm saying we start like...
We could do a new integral topic completely
on Friday.
and then go to review on Monday and then derivative test on Tuesday. We could do that. But then you have to consider the fact that you're learning something new. Then over the weekend you're practicing derivatives again. Then we're doing a review of derivatives on Monday and then a test on Tuesday.
The thing is that like if you do sometimes, I don't know for other people, but like if you do something new on Monday, people might get confused and...
I understand that, so I'm giving you guys the option.
Where's everybody else's opinion? So what do you guys want to do?
What do you think will be the best, Mr. Howard?
I don't know. Depends on what you guys are going to do this weekend as far as studying goes. It's up to you to answer that, not me. I mean, if we do slope fields and then review derivatives, I expect you to study over the weekend so that you can take the test on Tuesday, which means we're going to have a class there. If we do the new topic on Friday and then over the weekend, we're not going to review until Monday then. I don't want people not to review this weekend. So again, if we do a new topic on Friday, you have to review on your own over the weekend, and then we're going to review as a class on Monday.
Let's do that.
Whereas if we review on Friday, you're kind of continuing the review process over the weekend.
Now let's do it the other one.
Have a vote.
We need to have a vote, so people got to pick. If you don't vote, you don't get a voice here. So if only 2 people vote, we do what they say. So again, our options are either way, Thursday is slope fields, Friday, Monday, Tuesday. So
Just saying slope fields.
Friday could be either a new topic or review derivative. Monday could either be review derivative or the new topic, and then the test will be on Tuesday either way. You're pretty much deciding what you want to do on Friday and Monday. Now consider this again. If we do something new on Friday, you need to review on your own over the weekend. I'll give you some practice problems, and then we can review together on Monday and then have the test.
Yeah.
If we review together on Friday, continue that review over the weekend, but then starting something quickly new on Monday, and then going to the test on Tuesday.
This is like the Al Gore Bush election.
Okay?
It's
So,
so confusing that we don't know who we're voting for.
hands for row 1.
Well, that was funny.
Okay, that's pretty much easy.
Hands for row 2.
What's row two?
It wouldn't matter because
I'm
there were 7 for row 1. We have 12.
Oh, we have 7
votes.
That's my
Okay.
Wait, it's a new or review?
Hey, it doesn't matter. You got
Is
voted.
that this
Also,
That's this week, yes. So here we're going to do...
I'm still confused.
So review Monday.
Okay, this is the one I decided. Yeah. Okay. I told you this is like the Al Gore Bush thing.
Okay, so Friday's going to be intro to integrals now. Thursday we'll do slope fields, Friday will be intro to integrals, and then on Monday we'll review.
And that's-
Again, on Friday I'm going to give you the intro to integrals, but you need to review on your own over the weekend. Karen?
We have AP class after.
Oh, wow. I think
You know, that same day we
Oh,
Yes,
there you go.
we have class on Tuesday. Yeah.
Cool. I was like-
So if the test is too long, it might run into the afternoon. Again, guys, on Tuesday, your test, if it's more than 1 period, the after school part will be part of your test also. There's a good chance you're going to need that. I'll probably make it like an hour and a half test. So maybe like 45 minutes in class, 45 minutes after school. Okay?
Let's do it on Monday. I say back to Monday, but it's like...
I'm going to do multiple choice on part 2. So like, you can expect related rates to be a part 2. you could expect optimization or curve sketching to be part 2s. They could also be part 1s, but things like concavity or increasing, decreasing, finding the intervals of increasing, decreasing, that'll be like a part 1. Okay, the simpler problems are the part 1s, that's how you always think about it. The ones that take more thought are the part 2s. We'll talk more about that. What I want to give you, so you have an idea right now, is this. So here's what I'm going to give you. A sample review packet. I can find it.
What?
I'm from presentation.
So, as always, guys, as always, I try to explain to you. I literally searched application derivatives practice test. And somebody made a great practice test, and these problems are perfect. It's exactly what I was thinking, and take a look. The answers are already there, too. So please, guys, if you need more help, it is not just to come and see me, it is also to go ahead and take a look at other solutions. So what this is the following. Number 1, or the first part, asks you, can you listen? First part asks you, find increasing, decreasing, find concavity, find critical points, find inflection points, and then go ahead and try and sketch the graph of it. That's the first section. The second section, given the second derivative graph and the first derivative, graph the original. And we did this in class, go back to your notes. Given the derivative graphs, graph the original. That's the second problem. The third problems, or the third major section here, still curve sketching. Given the second and first derivative, graph the original. Now, remember what we did the other day with the table yesterday? We had the table with the increasing, decreasing, negative, positive, all that stuff. It's the same thing here, just like your curve sketching today. More curve sketching right here. On the back, given the graph, go from the graph to the table now. And we did that in class. We talked about how you can go backwards. Same thing. Next, just some general questions here. This is about max, mins, continuous functions, decreasing, increasing. Find the max, min, find the absolute max, min, find the relative max, min. Finally, the last page is what's the toughest part. The last page is all about optimization, related rates, all that kind of stuff on here. Okay? I don't think there's anything on linearization or differentials or slope fields. There's not on here. So what I'm going to do is give you problems from your textbook for that. Okay? The solutions are all here. The solutions for every single answer, every single problem are all here. Now, some of these don't show work, unfortunately. There's no work here. So if you get stuck along the way, come ask me. But you can check your final answer on this. I'm going to give this to you now. My face. I think I just got a piece. I did.
It's really good to roll the hair.
So, I'm going to give this to you today, guys. I'm going to give this to you today. You've got the next 1, 2, 3, 4, 5, 6 for the weekend. 6 days to study. Okay, so don't start studying tomorrow. Don't start studying over the weekend. Start tonight. Take a look at these problems. Maybe you want to juice the first 2. Okay, but break it up. Don't do this all the last night. It's not going to help you. Use your calculator on a lot of it. Okay, especially when you're finding the derivatives. For things like, finding the critical points, sometimes you can use calculators, sometimes you can't. Use your judgment. Okay, if the problems are all whole numbers, there's a good chance you're not going to be using a calculator on that. Okay? This is all going after your review of applications of derivatives. This is not for derivatives, but applications. Turn around.
Well, I go. Well, I go home.
Okay?
I'm gonna tell you. So why do you think that I go home?
First derivative is that's increasing, decreasing, min, max. There's a second derivative, it's concavity,
It's like
finally,
completely
sketch the curve check. So just go through, remember we did all those steps, the curve sketching?
Whoa.
So I checked it, right.
Go to 1 and 2. Hey.